Okay, hello. I have another set of notes for you. We're going to do this a little bit different, see which one works a little bit better. So you can't see me, but hopefully you can hear me. So I'm going to go through kind of an extension of the notes I gave on Monday. So there's another form of graphing that we can do. It's all the same type of parts, but it's just a new type of function. So that's why it's still the same section, but it's a little bit continued. Once we get into certain upper level topics, we actually get into some specific equations for it. And so exponential functions have a specific equation. And we've seen stuff like this before where they use a certain number and it keeps showing up multiple times. Then they called it something like with pi way back when. So today what we're going to talk about is the number e. And I know that sounds kind of weird, but again, E is actually a number. So if you ever looked at a calculator, a lot of times you see the letter E or sometimes an E to the X. That's because E stands for a number of it's called Euler's number. The guy who discovered this was working a lot with exponentials, and so his last name started with an E, so that's where the E comes from. It also ties into exponential as well. If you look on a calculator, if you type the letter E and hit equals, this number will appear. It is another number like pi where it's never ending, so it's an irrational number, and it doesn't repeat. So you don't have to memorize this at all, but I wanted to show you the first several digits of E so you can see what it looks like. Just like with pi, it was 3.14. Here, it's like 2.718 and so on. Okay? So that's going to be the number that we're going to use within all of our exponential equations. Now, like I said, we do treat it like any other exponential. It is a base, that's why it's called the natural base. So we have e, and then we raise it to exponents of x. So that's the most basic function you can have with e. Just like before, we can put numbers all around it. Put numbers in front, numbers in the exponent, and it can just be just x, or it can be multiple things. We can add stuff behind it. So it's going to behave in a similar way that our other graphs behaved. So let's do an example. So you should recognize these parts. So it's graph and snip. You're going to state the domain and range. So the domain will still be all real numbers, just like it was before. So it goes all the way left, all the way right, never stops. So you can use all real numbers still for domain. Range is going to be y is greater than something where it levels out at that asymptote. So these graphs are going to look the same. Growth and decay the same way, whether it's increasing or decreasing, increasing growth, decreasing decay, and then the x and y intercepts. So look at our first example. So we have y equals e to the x minus 5. So I'm going to go over to decimals real quick. So I can type that in. Again, you don't necessarily need the y equals, so I'm going to start with e. So even in decimals, when I type the letter e, it pops up this number. Notice it's italicized, so it's expecting e to be a number. So that's why we really never have used e as a variable. And then I'm going to use shift 6, and then I type my exponent x, and then minus 5. Again, I don't have to worry about putting anything else in the exponent here, so I don't need to worry about putting parentheses. So here's my graph. So again, notice it still behaves the same way. There's still a leveled part where the asymptote's at, and then it turns and shoots up. We have an x-intercept, so I'm going to highlight that point. Y-intercept, highlight that point, and then we're going to snip this. Again, I'm looking for good snips, so I want some of the leveled part. I want the part that jumps up. Make sure I highlight that point. Also, I need the x and y axis in there. So I'm going to start my snip kind of over here, click and drag, so I can get a nice snip. Again, I have the leveled part here. I see where it crosses the y-axis. I get the jumped up part where it crosses the x-axis. I can see both x and y-axis in my snip, so that's a good snip. So that's where I got my snip here. I already had it copied onto my screen. So that's part A. Again, part B, its domain still all real numbers. Again, it's still all real numbers. Sorry, I had to fix a couple of things real quick. So I still use the abbreviation ARN, so that's not going to change because again, if you keep going left and right on your graph, actually switch back to Desmos, even if you keep zooming in and out, notice the graph will still go all the way left. This one does shoot up, but as you can see, it's still getting closer and closer to that line. So it's moving over a little bit each time. So the domain's always all real numbers. Range, again, still y, and then greater than, and then where it levels out at. So I estimated that from the graph from -5. Also another reminder, it's this number can give you a helpful hint of where that range is going to be affected by. Okay. Next part, exponential growth or decay. If you follow this like you follow a book, as you go from left to right, it is going up. So this is a growth function. So it is exponential growth for part C. And then your x-intercept right here is highlighted, 1.609, and then your y-intercept is down here at -4. So again, this is all very similar to what we did before. The biggest difference is that base is a little different. It's now an e instead of just a regular number, because e itself is a number, so it behaves the same way as any other exponential base. Okay, I do have a second example that I'll show you now. Again, all the same parts, but we'll go ahead and do that second example. So I added a little bit more to this equation, so that way you can see me type it in a little bit more. Okay, so look at that last graph out of here. So we got -3, and then again, if you type e, e knows that, and actually it already did that math. It took -3 times e, which we don't want. So this one has a little bit more in the exponent. So again, the way I do that, if you do Shift-6, and then if I just type x plus 2, that plus 2 is supposed to be in the exponent. What you could do from this point, if you've forgotten that, you could actually highlight the plus 2 and do Shift-6, and that'll put it back up in there. So if you've already typed it in, that we don't have to delete it out. What I usually do, so I don't have to go back and highlight anything, you just put in an extra parenthesis in front of the x, and then do plus 2, it'll keep that 2 up there. Close the parenthesis now, and then now I can type the +5 that I have, and that way you can see it. Now this one, I can see the x-intercept, but if you notice, the graph kind of goes off the screen. So there are occasional times where you have to use your zoom feature, because like I said, you'll always have a y-intercept, you may not always have an x-intercept. So there's my x-intercept, and now I can see my y-intercept now that I've zoomed a little bit. So I had to zoom out a little bit, but again, you can see the flat part, and then where it jumps down. Okay, so in my snip, I need to get a good portion of all of that. So again, I have my leveled part. Now where it turns, hits the x-axis, y-axis, and then I'm going to get a good jump of that. So there's my snip for my second graph. And then do the parts, again, domain still always all real numbers, that does not change, so that's a nice consistent thing for you. Range, is going to be where this leveled part is. Now this graph, it is upside down, so this is the one time you could switch that greater than sign to a less than, but again, I'm not going to be super picky about that. So again, it is where that levels out at. From my snip, it's hard to see. Again, I just used the helpful hint of the last number always being the asymptote. It is a decay, because if you follow it along, it's straight, and then it jumps down. So since it's going down, it's a decay function. And then I got my x-intercept at -1.489, and my y-intercept down here at -17.167. So again, not a lot of differences between the different graphs. Again, the biggest thing is that now we've introduced e as a number. So now we can use it like we do anything else. Again, I'll post this online as well as a PDF version of these notes, and there'll be a little assignment for that. I was going to do 6 graphs, but I ended up doing 5 graphs for this, just like I did on the Monday's assignment. So again, if you have any questions, please reach out to me via email, and we'll go from there. Again, thank you. Bye.